sound that we're starting recording, and I'm gonna take Selvi and I from the spotlight, and we can start with the panel.
Okay, great. So the first part, all of you, all the panelists, we're just going to ask you to introduce yourselves. So Dr. Vray, could you please introduce yourself and share your name, pronouns, institution, and career level?
Hi, everybody. I'm Bianca Vray. I use she, her pronouns. I'm at the University of Washington. My virtual branded background doesn't currently look like this now, but it should be in like a month. And I'm a full professor, so that means that I've earned tenure. Means that I'm a lot older than the other panelists. I've been at University of Washington for 10 years.
Yeah, thank you so much. And Jessie, could you please share your name, pronouns, institution, and career level?
Hello, yes, my name's Jessie Laux Tavitas. I use she, her pronouns as well. I'm also at the University of Washington, and I am getting my PhD there in June. So I'm about to graduate and I'm about to be done with grad school forever, but it has been a wonderful time so far.
Great, thank you. And Nathan, could you please share your name, pronouns, institution, and career level?
Hello, everyone. My name is Nathan. I use he, him pronouns, and I also go to the University of Washington. And I'm a undergrad about to graduate, but yes.
Okay, so let's begin with the first question. Were you always good at math? Feel free to jump in whenever.
I guess I go first. For me, no, I was not always good at math. I went to a pretty poor high school, so I followed a really standard high school curriculum, and so like AP Calc and the things you would do in high school. And so like I guess I came into college with a very standard background. So I didn't know much about proofs. I came into college without knowing anything about proofs. So yeah, my background just standard, so pretty average.
Yeah, I would probably say the same. I honestly wasn't super interested in math. What changed that was actually my older brother was a math major, and then I decided that I wanted to be better than him at everything, and so I decided to be a math major too. And then I started paying attention to my classes, and then I was like, oh, this is fun. But yeah, coming into college, I had only taken up to pre-calc, so I was just starting off at calculus 1 and just followed the super standard path. I wasn't ahead or anything in terms of like in my freshman year, I took Calc 1 and Calc 2. In my sophomore year, I took Calc 3 and so on. So, but I really liked it and I didn't feel any pressure from my professors to be ahead or anything. And I appreciated that too.
Yeah, I would say that I think for like the school that I was at and my peers, I was maybe like good at math. But then you meet, if you stay in math, you keep meeting more and more people who have been like good at math or liked math for a long time. And so some of that includes people who like just recently got into it, but it also includes people who like knew they liked math from like age 5 and did all of these math circles and math camps and I didn't do any of those things. But I think it's also true that if you like went to my high school or middle school and asked people if anybody remembered me, assuming they remembered me because that was a long time ago, then they would probably be like, oh yeah, she was good at math then. But yeah, I always liked math, and I especially liked, well, I don't know that I knew, I think definitely in elementary school, most people don't think of like math as a subject that is ongoing. You're like learning how to multiply or whatever. But I really liked logic-y things. I liked logic puzzles and this game Mastermind and games like that.
Yeah, that's great. And because you were passionate about it, you enjoyed these different experiences. When did you know specifically that you wanted to pursue math, that you wanted to be a mathematician?
I guess I'll go again. So I guess my first motivation to pursue math was during my first year of college, and there I took a like real analysis course, and I really, really enjoyed the rigor of math, and that was what brought me first into math. Just wow, it's super rigorous to make sure everything is right, and I really enjoyed that. But then as I took on more math courses and realized how big of a field math was, like people could spend their whole lives studying certain subfields without knowing another. When I learned that, and I guess I realized my main motivation for math was kind of to see how those subfields that different people spent their lifetimes on kind of connect with each other. And just the connection between subfields of math is what is like my main motivation now. And that, I guess that was, I realized that around second year, so last year.
Yeah, I feel like we've kind of standardized the order now. Well, like I said, I was a math major because my brother was a math major. And so I just kind of kept taking classes and it's like, oh, I really like this. I think in general, I was always super interested in education. My dad's a community college professor. And so, like when I was in high school, I wanted to be a high school teacher. When I was in community college, I wanted to be a community college professor. When I went to a four-year university, I wanted to be a four-year university professor and so on. And so I felt like kind of every day was like a career day for me where I was watching my math professors just living their lives and thinking, I want to be just like you. One moment I do remember is when I was at community college, I was taking linear algebra, which is a sophomore level class that a lot of math majors and engineering majors take. And there are lots of proofs in it. And it's probably your first proofs class that you're ever going to take. And I remember all of my peers who were in mechanical engineering majors were like, I hate this class. This is so difficult and I don't like it. And I wish I could just do computations. And I just remember, and at the time I was actually considering changing to a mechanical engineering major because I was like, well, do I actually like math that much? Like I want to get a job, And so, but during that class, I kind of realized, oh, I really like proofs and I like theory and I like thinking about why things work. And I like that a lot more than the computations that we're doing in my calculus classes and in my differential equations class. So that was kind of a click moment for me where I thought, oh, maybe I should continue being a math major. And then once I transferred to Sacramento State, I started talking to my professors about like, oh, how did you do this? Oh, what does a PhD look like? And they kind of mentored me through, in my, I guess, junior and senior years of college to kind of help me figure out that I wanted to go to grad school and getting into research programs and stuff.
Yeah, I don't really think I had like one moment. I didn't know you could keep doing math like as a career. So when I started undergrad, I went to University of Maryland and I started as a computer science and math major because I liked math, but I just didn't know what job I could get with it. And I wasn't super drawn to teaching. I mean, I think it would have, like at that point. So I was like, well, computer science seems like you can get math with that, so I'll do both. And I just kept going on, and I had a really great undergrad advisor, and she told me about RAUs and told me like, okay, well, if you want to go on to grad school in math, you want to do these classes. And I was like, I don't even know what that is, but I guess I'll just take those because then it will leave the options open. Yeah, and actually I remember even when I knew about grad school, you like hear about the degree terms and I just assumed like I would first go get a master's in math and then I would go get a PhD in math, which it turns out, I didn't know this. So sometimes you can just go directly to a PhD. You get like a master's on the way if you want one, but you go directly, can apply directly to a PhD program. So I don't even remember when I learned that step. It was like some point, maybe junior year. Anyway, I just kept going. And I think at each time I didn't know what the next step like really honestly looked like when I made the decision, but I just knew that I was liking what I was doing and wanted to keep doing something like that.
Yeah, I think like one of the things you talked about where people just don't know that there are like more steps, like there's more to math than like just the school subject. I think that's another reason why we had this panel, is because we want to like kind of break that stigma. And basically, the question that we just had for you kind of leads into the next one, where we're asking like, what does it mean to be a mathematician for you?
Yeah. Okay. So, for me, at my current stage, being a mathematician is to just really, so yeah, at my current stage, at like undergrad, my day-to-day life of math is just taking classes and doing homework to build up my foundations to like do math in the future and do research in the future. And so just to be a mathematician is to just do a lot of math every day. And going back to kind of as undergrad and building up foundations, I guess there's also research opportunities as an undergrad. For instance, I'm doing a little project with a professor at UW as well. And also I did a little summer project at a different university. So there's a lot of opportunities to do research, but as undergrad, so it's just to build foundations for graduate school and in the future.
Yeah, I would say that in general, like I'm probably kind of right in between Nathan and Bianca, where I'm still building foundations and probably will be, they're more advanced foundations because I've taken all the graduate classes that I need to. But I'm still learning like stuff that hasn't been discovered yet. And I think that's generally the case just throughout being a mathematician, is that you're always, always, always learning more stuff. And I think for me, a big thing that I learned in grad school was that being a mathematician is also, it's not just about learning the material, but about learning how to think about the material and how to kind of wrap it up in a way that makes sense to you. And then also like being able to explain it to other people. So I think what I've learned the most from my mentors and professors is the kind of mindset of learning how to think about problem solving, learning how to think about math that you're learning. And then that all kind of builds up into doing research and like trying to figure out your own problems to solve and to prove. But yeah, I think right now being a mathematician means looking for a job. And like all reality of my day-to-day right now is just figuring out what my career is next and not actually a whole lot of math.
Yeah, I guess there's sort of two things to this question. What is like what I think being a mathematician means, and I think Jesse got at this. For me, it just means like sort of thinking with a mathematical mindset and approaching problems mathematically, like sort of trying to distill things down to their like most essential pieces or axioms, and then trying to think logically like what deduction follows from the next. And I think it's related but like slightly different than like an engineering mindset or a programming mindset. And for me, that's what being a mathematician means. So you could be a mathematician and have any job that could involve a lot of math, that can involve not directly a lot of math, but my job as a like academic research mathematician, so I think if you have a job as like that uses a PhD in mathematics, then actually I'm still learning. You're learning all the time because you're at the frontier. And so there's always, you're learning from what other people do, or you realize you need something from a different field. So you're learning about what people did a while ago, but you didn't work with it yet. So I still do a lot of learning in my job, but not directly. It's more like I need it as it comes, like maybe like, I don't know, a DIY house person. They're not like taking courses on like plumbing and how to big drywall, but like this project comes up and they're like, oh, I need to learn that. So that's how my learning is directed. Yeah, and then I also, a large part of my job is teaching and mentoring grad students. So teaching undergrads and grad students and mentoring grad students. So my week, the quarters that I'm teaching, next quarter I'm teaching linear algebra, the class that Jesse talked about, which I really like because it is a lot of students' first exposure to like what I would say is thinking mathematically less about doing the computations. And then right now I have 4 PhD students, so I meet with them once a week for about an hour and we talk about their problem and where they are, where they're stuck, sometimes more general career advice about like writing a math paper or giving a math talk or applying for jobs. Yeah, so my day-to-day is sort of a mix of that. Some days it's a lot of math and me learning on my own, and some days it's a lot of working with students.
Yeah, I think it's a really interesting part of math where, unlike other fields, math is really just the foundation of so many different fields. It's not just its own like singular field that's like entirely on its own. So being a mathematician is just it's so hard to define because you can be a mathematician and work in so many different jobs, so many different fields, and there's no like box you're stuck in. It's a really cool area to work in. So the next question, I think you guys already touched on this, but you could maybe talk more about like specifics. What does your day-to-day life involve as a mathematician? So maybe you could talk about like your routine, all of that.
Yeah, I guess so going back to taking classes. So I guess it's basically high school but harder and for me at least. So I mean, I wake up, I go to classes for a couple hours, maybe like 4 hours or so, with breaks in the middle, which is a lot better than high school. And then after that, for me, I would go to the library with some friends and just grind out some homework problems. And if I have some spare time, I may just, look up some math that I would like to research and like look into that a little bit more, or maybe go to office hour and talk to professors and see what they have to say about math. And also, I guess I would meet up with professors to do like research projects, but mostly every day is just class and homework, kind of like high school.
Yeah, I would say a weekly, well, again, like my routine is a bit off right now. But in general, a week probably looks like meeting with my advisor about once a week for an hour, and we'll just meet and we'll kind of talk about, like, I think what Bianca was basically describing is we'll meet and we'll talk about the problem that I'm working on, and if I'm stuck on something, he'll kind of give me an explanation or some his perspective on how he would go about solving the problem. And also he's been really helpful right now in just general career and life advice. And let's see, so once you kind of pick your research topic, there's seminars usually in grad school that you can go to. And so I'll go to the seminar, the algebraic geometry seminar, where we'll have a speaker come from outside. And that's kind of like my structured learning time because I'm not really taking any classes. But it's like basically an hour-long lecture from a professor on their research area. And that's usually where I'll get like, oh, this is what people are learning, or this is what people are thinking about right now. And like, maybe I should take their techniques and put it into my research. as a grad student, you also teach classes or maybe TA classes. So right now I'm grading a class. So usually a couple hours a week I'll be grading or holding office hours. Sometimes I teach my own class, so then I'll be prepping lectures. And yeah, and then the rest of the time is like either talking to friends and peers about math or talking to maybe other mentors about math or sitting in my office with the door closed and the lights off and thinking about math. Or maybe I'll pull up a paper on my computer and like try to read that and try to kind of like what Bianca was saying, like distill it down to something a bit more understandable for myself. And the point of that is to, you know, build up my mathematical foundations, my thinking skills.
Yeah, I talked in broad strokes about this, and I think a lot of like learning and research is similar to what Jesse described. Maybe I'll explain something that I think doesn't get as much airtime, I think, in pure math, which is that I actually spend a lot of my time trying to think about how to explain what I've proved, or like the meaning of it, or how to think about these results. And so like right now I'm in the last stages of wrapping up 2 papers, which is like we have our theorems and we know we like have the proofs for them, but it's like earlier in math, okay, if you have something like 2 + 3 = 5, like there's not too many ways to think about it. Like, okay, if I have 2 apples in this basket and 3 apples in this basket, and then you add them all together, and then that's the number we label it as. But like sometimes it's hard to math is like trying to encapsulate like this understanding that we have of these objects into like a precise concrete statement that like from this thing implies this thing. Like I don't know, like if you're outside in the rain, then you will get wet. You know, like but sometimes that doesn't explain. It's hard to get all of like that. Like really what I want to do is transmit all of the understanding that is in my brain that I like built up over that. Just like directly take it and like input it in Jesse's brain, or like, you know, everyone else I'm talking to. And it's like really hard to do that. So that's a lot of the end stages of a project is figuring out how to like summarize and synthesize this understanding, and like why we chose this project and why we think it is useful for other people to understand. And yeah, so there's actually, yeah, that's a thing that I spend a lot of time on. And for me, I think actually doing that work helps me understand other things better. So it's not only like self-serving in terms of being able to communicate my ideas for other people, it's also self-serving in that it like helps me understand things better and figure out what to prove next.
Yeah, I think that's like also one thing they talk about in school, like teaching something like you just learned to like somebody else will like help both you and the person. So yeah, I think that's definitely like a very important part of not only math, but I think like any field where like people need to expand upon each other. And the only way to do that is through communication. And if you don't have proper communication, well, there's going to be a problem there. So for like students who are interested in going into math, going into like future career pathways in math, that sort of thing, like going into the field of math in general, what advice do you have? And feel free to elaborate as much as possible.
Yeah, I guess I'm not the best person to ask this because I probably need the advice as well. But I guess I have 2 things I want to say. So I guess in terms of learning math, the best thing for me was to kind of actually, you may hear this all the time, but actually like read the textbook and do the homeworks. I guess that's where I learned the most. But more generally, I feel like kind of my second advice is to more generally kind of reach out to people. I think I got my best opportunities from talking to professors or grad students or just people with more seniority than me. Yeah, for instance, like my first year, I reached out to my math TA, and he let me into this reading group, which taught me a lot of math and made me realize I wanted to pursue it more. And I also, another instance of this was when I just reached out to professor, and I got a little research project going on, and kind of, yeah. So reaching out to people is the most important thing for me.
Yeah, I think I would echo those two things, of just like making sure that you're putting in the time to actually understand what's going on. I think sometimes in math classes, especially in middle school and high school, it's really easy to kind of figure out, okay, what's the process that you're doing? Okay, I'm going to just kind of plug and chug. Like if your teacher's ever said that, just plug and chug until the problem's done, and I'm not going to think about what's going on. But a lot of math is trying to actually understand what is going on behind the scenes. So you don't need to think about it every single time you're doing a problem, but like making sure that you understand, I'm doing a long division problem. Okay, can I think about to myself, like, why does long division work? Or like if I'm solving an algebra problem, why could this be useful in real life? And yeah, I think talking to professors and mentors is really helpful as well. Something I wish I'd done is talk to people who didn't go into academia, like get their PhD, because then maybe I would have, tried to maybe I would have then known about more career paths besides just going to grad school. I'm really glad that I did, and I love academia, but I think some people go to grad school and then realize they don't like it, and then they have no idea what to do afterwards. But I think in general, like if you once you're in college and even in high school, you can really like haunt your professor's office, and hopefully they won't mind too much, and just ask them all of your questions about life. And my professors in college were really, really formative for that, and just giving me advice about life and grad school, and kind of what comes next and what I might need to do to get where I want to go. And yeah, they're really awesome, and they continue to be like good friends to this day.
Yeah, everything that was said so far, I agree with. I think because what we talked about before, like math relates to so many things, I don't think there's necessarily like one, okay, you should take this class and you should do this thing. And I think you should follow your interests. Like if you really are doing, plug and chug and you're like, but why are we doing this? Why does this work? Or why is this plug and chug the same as like this other plug and chug? I would just like follow that train of thought and try to think through it. And then maybe that suggests that you really like pure mathematics and want to study in that. But if you're like, oh, this like is so many steps, can I do this faster? Or like, we could just do this on a computer. Why? Maybe you want to study like applied mathematics or computational mathematics or algorithmic things. And you could follow that. But I think trying to pay attention to like what you really like, and it's okay. Like if somebody had asked me this in high school, I would have been like, I don't know. I just like math. Like I like I like thinking about this, and I wouldn't have been able to articulate it, and that's fine. I like that's also fine. But I think there's so many things that you can get on this path, and then also like Jesse was saying, academic mathematicians, we're really like we only have experience with academic math jobs. So we're really bad at giving advice on other career paths because like that's not ever something that I have experienced. So it's easy to get on a path and like have it be this echo chamber of advice, which like if you are liking it and continuing it, that's totally fine and that will work out for you. But if it's not a total fit, then you might need to find other people to talk to who are maybe a bit more removed. So just like paying attention to your own inner voice of like, actually, I don't like this. And it seems like a lot of other people like do like this part, but sort of like what Jesse was saying about the mechanical engineering students and linear algebra, you know, figuring out like, okay, these people who do these things like this, and I also like this part, or I don't like this part. Like, there's a lot of different ways that you can do math, and that you want to find the way that's best for you.
Thank you. Yeah. So I think the biggest takeaway, since I know a lot of people had this question, like, you know, if I'm a middle school or high school student, what should I do to pursue math? The main takeaway is there's no like equation, like I should do this and this. It's just such a versatile field, and there's so many different career options, different paths you can take, that really just explore your passions, talk to people, and you'll figure it out what you want to do. So that was our last question, actually, our last interview question. So we're going to do a quick break, and then we are going to move. Sonia will share her screen with the Mentimeter quickly. So basically, we are going to be taking audience questions now. So some of you already submitted audience questions. When you registered, there was one of the last questions. You could submit a question. So if you did, we went ahead and put those in. So Sonia's going to share her screen. Yeah. So basically, when you open this website, and I think it's also in chat, yeah, or you can scan this QR code. You can vote on questions that other people have asked. You can like upvote questions if you really want to hear one, or you could submit your own question. So yeah, you can go ahead and scan that QR code, or use that code on the top and open it on your website. And yeah, so this will be like a brief break and audience questions submission time.